Hello students, so welcome again. Here I am with another problem on sections of solid, one of the very interesting problem. If you remember that earlier we have solved a problem like that, from a cube we got a regular hexagon. So similar type of problem will be again here, a simple solid that will be a square prism. So a square prism will be given to me. Dimensions will be base side 35 mm and axis 120 mm, and we want to keep its base on the HP, and we want to cut this solid by an AIP in such a way so that the true shape of the section will be a rhombus, and we want a rhombus of size true shape will be a rhombus of diagonals 100 mm and 50 mm. So in this problem they have told that there will be this square prism will be given to me, and I have to cut this in such a way so that the true shape of the section will be a rhombus of 150 mm diagonals. So as we want to get the rhombus, so you know that if we want to get a rhombus, then we have to place our square prism with the base on the HP with all the base sides equally inclined to VP. So initially I have drawn this figure, and in this figure I have kept all the sides of the square inclined 45 degree to the XY. The base side will be 35 mm, and with the help of that I have drawn the front view. Now if mathematically you can find out, then this side will be 35 and this side will be 35. So automatically this diagonal of the base will be 50 mm. That's why we can get the second diagonal, that is 50 mm. So that puzzle will be solved because the length of this BF, or you can say BD and FH, will be 50 mm. So by putting it like this, now we are going to cut this solid by an AIP which will be inclined to HP and perpendicular to VP, and as I want to get the diagonal, second diagonal 100 mm. So what I will do, that I will take the length of AIP equals to 100 mm. So for making that, what I will take this length, that is 50 mm from the top view, and from the center of the axis. Actually what I am doing, I am bisecting this axis. So I am taking the midpoint of the axis, and I have marked 50 mm upside and 50 mm downside, like this. So my section plane will be passed like this. So now look at this section plane. What we have done, by picking the midpoint of the axis, I have taken this radius equals to 50 mm. So I have taken an arc of 50 mm length. So if this will be 50 upside, downside, that is also 50. So cutting 50 mm in both the side of the square prism, what I will got? I got the length of the AIP, that is equals to 100 mm, and you can also mention this AIP by VT. So this is the VT of the section plane. Now if I want to go for the top view, then you know that all the 4 points in the top view will be on the corners of the square in the top view, if I mention those cut points, then this will be my point 1 dash, this is 2 dash, this will be 3 dash, and this will be 4 dash, and in top view this will be 1, this will be 2, and this will be 3, and this will be 4. Now for getting the true shape of the section plane, you know that what we will do, we will draw a reference, another new reference line parallel to this cutting plane. So if I draw a new reference line parallel to the cutting plane, and I will project it on that. So what I will do, I will draw another reference line parallel to this cutting plane, that is my x1 y1, and on this x1 y1 I will project these points 1, 2, 3 and 4. So from 1, then from 2 and 4, and finally from 3. Now I will pick the distances from the front view, top view. For the true shape, you know that the distance of the new top view from the new reference line is the distance of the old top view from old reference line. So this will be the distance of 1. I will pick from here and mark on this, that will be point 1. Same way 2 on this, 4 on the same line, and 3 on this line. So these are the 4 points I can easily get. So this will be 1, this will be 2, 3 and 4. Now join all these 4 points with the help of straight lines. You can easily get the true shape of the section. Now draw lines inclined 45 degree to xy, to new xy, section lines equally spaced, inclined 45 degree to xy, so this is the solution of the problem, and you can easily find out this inclination of the AIP, that is theta, and as this length will be 100 and this length will be 50, so this theta will be 60 degree. So this is one of the problem in which we can get the true shape of the section by cutting a square prism in such a way so that the true shape of the section will be a rhombus of diagonals 100 mm and 50 mm. I hope you understand the concept, and now you are able to solve the problems of the similar types. Thank you very much.